Hello students, welcome to the science class. Today we are going to discuss about the chapter sound. In our daily life we come across many kind of sounds, isn't it? Sounds comes from various sources like humans, birds, bells, machines, vehicles, televisions, radios, etc. Sound is a form of energy which produces a sensation of hearing in our ears. There are also other forms of energy like mechanical energy, heat energy, light energy, etc. And we have been taught about conservation of energy, which states that we can neither create nor destroy energy. We can just change it from one form to another. See, when you clap, a sound is produced. Can you produce sound without utilizing your energy? See, I am standing. See, I haven't produced any sound because I have not produced or I have not utilized any kind of energy of myself. Okay, so which form of energy did you use to produce sound? In this chapter, we are going to learn how sound is produced and how it is transmitted through a medium and received by our ear. Okay, so the first thing we are going to discuss is production of sound. Fine. So students, to produce a sound, an activity is given in your book, that is activity 12.1. It says take a tuning fork and set it vibrating by striking its prong on a rubber pad. What is a tuning fork? Students, tuning fork is an instrument which creates vibration when we strike it with something. Okay. You can feel that vibration when you touch it with your finger. So in this activity, suspend a table tennis ball or a small plastic ball by a thread from a support. Take a big needle from a thread, put a knot at one end and then with the help of the needle pass the thread through the ball. Touch the ball gently with the prong of a vibrating tuning fork. Observe what happens and discuss with your friends. You can feel the vibration in your finger when you touch the tuning fork and you can feel some kind of sound as well. Now in activity 12.2, you have to fill water in a beaker or a glass up to the brim. Gently touch the water surface with one of the prongs of the vibrating tuning fork as shown in the diagram given in your book. Next, dip the prongs of the vibrating tuning fork in water. Observe what happens in both the cases. Discuss with your friends why it happens. In the above activities, we have produced sound by striking the tuning fork. We can also produce sound by plucking, scratching, rubbing, blowing or shaking different objects. Let us do it. Okay? See, when I shake the bunch of keys, we create sound. See, when I rub these two objects with each other, you can clearly hear the sound. When I rub my palms, I can also hear some kind of sound. Students, when I clap my hands, I hear sound. So, we can produce sound by some other ways as well. So, students, as for the above activities, what do we do to the objects? We set the objects vibrating and produce sound. Okay? We will discuss all the concepts in this class, okay? Not to worry, just first of all, you do all these activities and you just think about what happens through these activities. Not to worry, we will clear all the concept in this class, okay? So students, from these activities, what do you conclude? Can you produce sound without a vibrating object? In these activities, we have produced sound by striking the tuning fork. We can also produce sound by plucking, scratching, rubbing, blowing or shaking different objects. You all know about the guitar. How the guitarist play a guitar? It plugs the strings of the guitar. Same way, when we play any kind of other musical instruments, we create some kind of vibration. You may have seen the dholak or tabla. There also we strike them with our hand, thereby creating the vibration in the surface. We set the objects vibrating and produce sound. Vibration means a kind of rapid to and fro motion of an object. The sound of the human voice is produced due to vibrations in the vocal cords. See, now you can hear me because vibration is being created in my vocal cords. When a bird flaps its wings, do you hear any sound? Think how the buzzing sound accompanying a bee is produced. A stretched rubber band plugged vibrates and produces sound. If you have never done this, then do it and observe the vibration of the stretched rubber band. You can look around yourself and you may find many things which create vibration and thereby producing sound. See, zzz, I am creating vibration through my mouth, through my tongue. Okay, my vibration reaches you through a medium. We will discuss about this propagation of sound in this class as well. So, need not to worry. There is another activity for you, that is activity 12.3, that is to make a list of different types of musical instruments and discuss with your friends which part of the instrument vibrates to produce sound. I have already told you about the guitar and the dholak, the tabla. Same way you can list out many instruments because all the musical instruments, they produce different kind of sound by the vibration at different parts of their body. Okay. Now we will find how the sound propagates. Okay. Sound is produced by vibrating objects. Fine. The matter or substance through which sound is transmitted is called a medium. It can be solid, liquid or gas. Sound moves through a medium from the point of generation to the listener. When an object vibrates, it sets the particles of the medium around it in vibration. Students, a particle of the medium in contact with the vibrating object is first displaced from its equilibrium position. What does it mean? Equilibrium position means the position or the initial position when it is at rest. That is its equilibrium position. Sound needs a medium to travel. In our case, while giving this lecture, sound is produced by my vocal cords and it is reaching you through a medium. And in the same way, when you talk with each other, you can talk to another person or the other person hears you through a medium. Let you be at a distance. You might think how my voice or the sound which is produced by me is reaching another person. So, there is something called a medium through which it passes. In your case, it is the air. Through air, sound travels. Whatever you say, it reaches your friend or the person who is hearing through air. In this class, we will see how sound travels through air. It then exerts a force on the adjacent particle. Because of the vibration, a force is being generated and that force is being transferred from the particle to the particle ahead, as a result of which the adjacent particle gets displaced from its position of rest. After displacing the adjacent particle, the first particle comes back to its original position. This process continues in the medium till the sound reaches our ear. The disturbance created by the source of sound in the medium travels through the medium and not the particles of the medium. We have known that motion is being generated when force is applied, isn't it? A body comes to its state of motion from state of rest when we apply force. So by this force which is exerted by the vibrating particle, the particle that is ahead is displaced from its position of rest. The first particle does its work and comes to its initial position, isn't it? See, you might be thinking the particles are moving, because we know that they move or they come to their motion state from rest state when we apply force. But as I have already told you, when they exert force and displace the other particles, they come back to their original position or the initial position. So they do not move ahead. They create a disturbance between themselves, and that disturbance keeps on moving ahead till it reaches our ear. So a wave is a disturbance that moves through a medium when the particles of the medium set neighboring particles into motion. That means it creates a wave. They in turn produce similar motion in others. The particles of the medium do not move forward themselves, but the disturbance is carried forward. This is what happens during propagation of sound in a medium. Hence, sound can be visualized as a wave. Sound waves are characterized by the motion of particles in the medium and are called mechanical waves. Students, let us now observe how this wave is being formed. Okay, as we have discussed about the vibration of particles, so what does it mean? When sound moves, the vibration is being generated in the sound particles. That means they move up like this, come to a certain position, they come back, they go down, and they again come up to their mean position, thereby constructing the wave. So this is called your sound wave, which moves along and it keeps on with the intensity of the sound. It keeps on decreasing and decreasing. At certain stage it is not audible, because with the flow of time or distance, the intensity of sound keeps on decreasing. So at a certain stage the sound will be negligible to hear. Hope you understand how the sound wave is being generated. Students, air is the most common medium through which sound travels. When a vibrating object moves forward, it pushes and compresses the air in front of it, creating a region of high pressure. That means as the particles move ahead, okay, they move ahead, and as they move ahead, they dislocate their position or they relocate themselves ahead. They leave their initial position and they go ahead. That means in the position ahead they create a compression, because there is a space and there are particles there, but the particles from behind, they come closer and they compress the air in front of them. So this region is called a compression, which is denoted by C. Compression. C. Fine. And this compression starts to move away from the vibrating object. Compression always moves ahead. As you can see in your diagram given in the book, the compression always moves ahead from the vibrating object. When the vibrating object moves backwards, it creates a region of low pressure that is called rarefaction and denoted by R. So, as the object moves back and forth rapidly, so they are moving back and forth. Suppose this is the vibrating object, and when it vibrates, it goes to this place and comes back to this place. Okay, so the particles over here, they move ahead and they displace the other particles. When they reach over here, they create a high pressure area. When they come back again, when it comes back to original position, then the particles move backwards and thereby creating low pressure area. So they move away from the vibrating object. So in this way the disturbance moves forward. So this is your compression and this is your rarefaction. Okay, compression and rarefaction. So pressure is related to the number of particles of a medium in a given volume. More density of the particles in the medium gives more pressure, as I have already discussed that when the particles move ahead, they create the more number of particles in this position. So by more number of particles, high pressure is generated over here. So as they move forward, okay, they create low pressure because now for a certain amount of area there are less number of particles. So as there are less number of particles there in a fixed region, the pressure gets decreased and there is a low pressure. Okay. So thus propagation of sound can be visualized as propagation of density variations. See, there is a density variation, it is a high dense area, it is a high dense area, it is a low dense area, and this continues as you can see in the figure given in your book. So we can conclude that propagation of sound can be visualized as propagation of density variations or pressure variations in the medium. Okay. Students, let us now discuss question that is given in your page 162. It says, how does the sound produced by a vibrating object in a medium reach your ear? So we have already discussed it. So what should be the answer? Air is the commonest material through which sound propagates. When vibrating objects like prongs of a tuning fork move forward, they push the molecules of the air in front of them. This in turn compresses the air, thus creating a region of high pressure and high density called compression. This compression in the air travels forward. When the prongs of the tuning fork moves backward, they create a region of low pressure in the air, commonly called rarefaction. This region has low pressure, low density and more volume. As the tuning fork continues to vibrate, the regions of compression in the air alternate with the regions of rarefaction. These regions alternate at the same place. The energy of vibrating tuning fork travels outward. This energy which reaches the ears makes the eardrums to vibrate and thus we hear sound. Students, hope you understand the solution for the question. Now students, let us discuss sound needs a medium to travel. We have already discussed it, but let us prove it. Okay. Sound is a mechanical wave and needs a material medium like air, water, steel, etc. for its propagation. It cannot travel through vacuum, which can be demonstrated by the experiment which is given in your book. So let us discuss that experiment. What it says, take an electric bell and an airtight glass bell jar. The electric bell is suspended inside the airtight bell jar. The bell jar is connected to a vacuum pump as shown in your figure. What does a vacuum pump? A vacuum pump is such an instrument which can vacuumize any volume. Okay. If you press the switch, you will be able to hear the bell. Now start the vacuum pump. When we start the vacuum pump, air in the jar is pumped out gradually. The bell is still ringing. You can see it from outside. Okay. The bell is still ringing because it is in switched on position. But as gradually the air is pumped out, the sound becomes fainter. That means it fades out. The loudness of the sound decreases. Although the same current is passing through the bell, after some time, when less air is left inside the bell jar, you will hear a very feeble sound. What will happen if the air is removed completely? Yes, you cannot be able to hear the sound though the bell is still ringing. That means as sound does not have the medium to pass through, which was previously the air inside the jar. As the air inside the jar is being pumped out, so it has lost its medium to travel. That's why we can't hear the sound, though we can see that the bell is still ringing. Okay, so it proves that sound needs a medium to travel. Okay, so students, let us discuss some questions. Those are given in your page number 163. Question number 1. It says explain how sound is produced by your school bell. Okay, let us discuss this. Fine. Students, let us now discuss the solution for this question. Air is the commonest material through which sound propagates. When school bell is rung, it pushes the molecules of the air in front of it. This in turn compresses the air, thus creating a region of high pressure and high density called compression. This compression in the air travels forward. When the bell moves back, it creates a region of low pressure in the air, commonly called rarefaction. This region has low pressure, low density and more volume. As the bell continues to vibrate, the regions of compression in the air alternate with the regions of rarefaction. These regions alternate at the same place. The energy of vibrating bell travels outward. This energy which reaches the ears make the eardrums to vibrate and thus we hear sound. Okay? Hope you understand the solution for this question. So students, when the gong strikes the bell, vibrations are produced in the bell which are transmitted through the air to our ears. So these vibrations which are produced in the bell, as they travel through the medium, that is air, they reach our ear. So these vibrations produce sensation of sound in our ears. So in this way, sound is produced by our school bell. Fine. Sound is produced because of the vibration of the bell. So it creates disturbance. That disturbance is being travelled through the medium, that is air, through compression and rarefaction, and it reaches our ears. That's why we hear the sound of the bell. Okay. Question 2 says, why are sound waves called mechanical waves? Okay. So the answer should be, some mechanical energy is required to make an object vibrate. Sound energy cannot be produced on its own. The mechanical energy of vibrating object travels through a medium and finally reaches the ear. Therefore, the sound waves are called mechanical waves. Sound waves are called mechanical waves because they need a material medium to travel. So, they need a material medium to travel. They need either air, water, any metal. Okay. So, they need a material medium to travel. That's why they are called mechanical waves. Okay. The next question, question number 3 says, suppose you and your friend are on the moon. Will you be able to hear any sound produced by your friend? What should be the answer? On the moon, sound cannot travel as there is no atmosphere. Sound cannot travel in vacuum. So, we will not be able to hear any sound. Hope you understood all these questions. Students, let us now discuss sound waves are longitudinal waves. An activity, that is activity 12.4 is given in your book. It says, take a slinky. Ask your friend to hold one end, you hold the other end. Now stretch the slinky as shown in figure 12.7a that is given in your book. Then give it a sharp push towards your friend. What do you notice? If you move your hand pushing and pulling the slinky alternatively, what will you observe? If you mark a dot on the slinky, you will observe that the dot on the slinky will move back and forth parallel to the direction of the propagation of disturbance. It always moves parallel to the direction of the propagation of the disturbance. Okay? The regions where the coils become closer are called compression. So, when we stretch and leave, or we can pull and push, what happens? We can see that some parts of the slinky, they are close to each other, okay, and some parts are away from each other. So, the closer coils, they are called compressions, and the reason why the coils are further apart are called rarefaction. As we already know, sound propagates in the medium as a series of compression and rarefactions. Now, we can compare the propagation of disturbance in a slinky with the sound propagation in the medium. These waves are called longitudinal waves. Okay? In these waves, the individual particles of the medium move in a direction parallel to the direction of propagation of the disturbance. The particles do not move from one place to another, but they simply oscillate back and forth, okay? They oscillate back and forth about their position of rest. This is exactly how a sound wave propagates. Hence, sound waves are longitudinal waves. There is also another type of wave called a transverse wave. In a transverse wave, particles do not oscillate along the line of wave propagation, but oscillate up and down about their mean position. So, see, my mean position is fixed, and suppose the right hand is a particle, so it is moving up and down. Thus, a transverse wave is the one in which the individual particles of the medium move about their mean position in a direction perpendicular to the direction of wave. So, this is the direction of wave, and the particles, they propagate up and down, that means they are perpendicular to the medium of wave or the direction of wave. Okay. Students, with this we come to the closure of this session of science class. Today we have discussed about some concepts of sound, its characteristics, and we have solved some questions. In our next class, we will discuss some more concepts of sound. Till then, revise everything that you have studied today. Keep practicing, keep smiling, stay safe. Thank you.